Welcome to Meetings in Math. You are here for section 7.1 and 7.2, evaluating expressions with roots. Our essential question is, how are expressions with square and cube roots evaluated? And how did cube and square roots fit into the order of operations? Today you will need your Jaguar dots on section 7.1 and 7.2. Your pencil and a pen. You may find a highlighter helpful. Leave your calculators behind, but you can replace it with a multiplication table. Your self-confidence, your best effort, and always bring your problem-solving skills. Let's start with a reminder of what a square root symbol looks like and a division sign looks like. The square root sign kind of has like a check mark in front of it, where the division symbol is just a straight, almost like a table. You need to make sure that you understand the difference. This right here tells you that you're putting it into groups, where this one right here, you are looking at how many times you're multiplying it by itself. And so they are doing very different functions. And so you have to understand and remember what that means. And then sometimes we even go a little bit further and we put a number here. And so this one is, we're multiplying it by itself 3 different times. And so this one has to do with powers. So for example, 7 to the third. So we would go 7 times 7 times 7. And then this right here would be undoing that. We would put the number in here, and then we would undo that, and then the answer would be 7. And so they are doing very different things, and we need to remember that and make sure we are clearly identifying what it is that we want to communicate. So in our first example, we are doing 2 times the square root of 144, 2 root 144 minus 30. Usually you hear it say 2 root 144 minus 30. And so we need to remember what things mean. For example, evaluate means simplify. So that means to us that we're not going to have any perfect squares under the square root symbol anymore, and that we are going to make it as simple as we can. So this 2 root 144 means 2 times. So when we see the number right next to the square root, it means multiplication. And so the first thing we want to do is we want to simplify the square root. So what's the square root of 144? It's 12. So that's where they fall into place. They're almost like a parenthesis. So you want to simplify what's under the square root first. And so the square root of 144 is 12. And so now we want to do 2 times 12, which is 24, and then 24 minus 30, which is negative 6. So where do they fall in place? They act like a parenthesis. So now let's look at B. 49 minus the square root of 49 squared. So now we need to work inside the parentheses first, and we need to do the square root of 49. And so the square root of 49 is 7. And so now we need to do the 7 squared because order of operations says we need to do exponents before we subtract. So we are squaring the 7. The subtraction sign is outside of the parentheses, so it's just going to drop down. So we squared the 7 and we got 49. And 49 minus 49 is 0. So on C, we have to remember, what do we do when we see a fraction inside of a square root? Well, we need to remember that we can break this into the square root of 36 over the square root of 4. So the square root of 36 is 6, and the square root of 4 is 2. And then we need to find common denominators. So I'm going to multiply 6 halves by 3 over 3, so that I have 6. So 18/6 plus 1/6 is 19/6, and I'm going to go ahead and leave it at 19/6. I'm not going to make it into a mixed number because we don't need to. It means something that's just perfectly understandable. So 19/6 is where I'm going to leave it. If it was, say, 18/6, I would have to make that 3. I would have to completely finish simplifying it. So again, remember, when the 3 is next to the square root of 25, it means 3 times the square root of 25. So now that I gave you that little bit of help, I would like you to pause this and do this one on your own. All right, now that you've done this on your own, let's go ahead and go through how to do it. So the first thing we need to do is simplify the square root of 25 because that is like parentheses. So that's kind of where it fits in here. So we have 12 minus 3, and then what goes in the parentheses? 5. So now order of operations says do multiplication. So 12 minus 15, and 12 minus 15 is a negative 3. So here we have 3 times the cube root of 125 minus 8. And that's how we read this, is 3 times the cube root of 125. It's just like a square root, except for it's a cube root. And then we're going to subtract 8. So 3 times the cube root of 125 minus 8. Well, how do we deal with that cube root of 125? You may have forgotten. So we take the 125 and we break it into 5 and 25. And then the 25 is 5 and 5, and we pull down that 5. So the cube root of 125 is 5 because we have the triplets right here. We know that in triplets that only one comes out and the other two disappear. So now we follow the order of operations. 3 times 5 is 15, and 15 minus 8 is a 7. So now this one starts looking a little bit scary because we have a negative, and sometimes that's a little intimidating, but don't let it get the best of you. Just remember, though, that this is 4 times the cube root of negative 729. And then you're going to add the 2. So we have 2 plus 4, and then whatever that cube root of negative 729 is what we're going to substitute in. So I have the 729, and I break it into 9 and 81. How did I know it's 9? I know some multiplication rules, I'd say, are testing rules. 7 plus 2 is 9, plus 9 is 18. And 18 is divisible by 9, which means I know the whole number is divisible by 9. And then I continue to go on, and I know that 81 is 9 times 9, and that's 9. I could have continued on until I had 3's and done a whole lot, but I know I have triplets right here, and that's enough. So now I'm going to put 9 in for here. Well, not quite though. Because this is a negative 9, all the numbers have to be the same. So this is a negative 9, and so we know that this has to be negative 9, because negative 9 times negative 9 times negative 9 does make negative 729. How do I know that? Because when I have a negative times a negative times a negative, the first 2 negatives become positive, and the second one becomes negative. And then a positive times a negative is negative. And this is true for all cube roots. Whenever I have any cube roots, this is going to be true. So I'm going to actually replace it with a negative 9. So now 4 times negative 9 is a negative 36. So it's 2 plus a negative 36, which is negative 34. So why don't you go ahead and pause this one and try it on your own and come back and see how you did. So this one is saying that we're going to cube the cube root of 27, and then we are going to subtract 4. So we're going to cube the cube root. So we need to go find out what the cube root of 27 is. So 27, I know, is first of all 3 times 9. And then I know that 9 is 3 times 3, and I write down the other 3s. So I can replace the cube root of 27 with 3. And I know that 3 times 3 is 27, and so 27 minus 4 is 23. So on H, we're going to evaluate W divided by 30 minus the cube root of W divided by 5 when W is equal to 1080. So we have to begin this problem by actually substituting in for 1080 for W. So that's what your first line should look like. 1080 divided by 30 minus the cube root of 1080 divided by 5. Now in this case, it doesn't actually make sense to find the cube root of 1080 and the cube root of 5 because we don't know the cube root of 5. In fact, it doesn't exist because I can't break 5 into anything smaller since 5 is prime. We're actually going to go ahead and divide 1080 by 5 and get 216. And then continue to simplify from there. So what we need to know then is the cube root of 216. We're going to go back to our handy dandy little factor tree. So 216, I know that the last 2 digits are divisible by 4. And since the last 2 digits are divisible by 4, the whole number is divisible by 4. If I didn't know that and all I knew was 2, that's okay. It's just going to take me a little bit longer to get through my factor tree. So 4 times 54 is 216. And I know that my 54 is 9 times 6, and my 4 is 2 times 2. And so my 2's are dealt with, and I'll just bring those down to my next layer. And my 9 and my 6, I know 6 is 2 times 3, and 9 is 3 times 3, and then my 2's I'll bring down. Now those are all nice primes, so I'm going to gather those all up into their nice little groups. So I have 2 times 2 times 2 and 3 times 3 times 3. Well, that's nice. My 2's are, there's a triplet, and there, I also have some triplets of 3's, which means I have a group of 2 and a group of 3. So now I have 360 minus 6, which is 358. So now we've done quite a few examples. What I'd like you to do is I'd like you to finish by answering this question. Where do cube roots fit in order of operations? Thank you so much for joining us in this lesson today, and I can't wait until we see you in the next lesson. Remember, be kind to one another because we all can use some extra kindness in our lives. Bye for now.